In this video, we're going to learn how to add and subtract rational expressions. This is the third time we've worked with rational expressions. We know rational means fraction. It's a rational expression because we've got polynomials and the numerator or the denominator or both. The first time we looked at these guys, we just looked at how to simplify them. And then we looked at how to multiply and divide. And now we're just going to finish off by learning how to add and subtract these things. So just like what we started with multiplying and dividing, to figure out how to multiply and divide a rational expression, we first looked at doing that with just rational numbers, fractions. So let's do the same thing for adding and subtracting. How would we add these fractions together? We know that we can't add or subtract fractions unless the denominators are the same. So I'm going to actually change this guy up a bit. I'm going to change this guy over here to a 3. It's just to make them a little bit different. So here we're going to add these guys together. We have to make the denominators the same. So we got to just think creatively. Can I make the 2 look like a 4 by multiplication? So I'm not going to add 2 to make the 4. I have to use multiplication. I have to multiply by a factor. And I can multiply by a factor of 2. So if I multiply this denominator by 2, then the denominators would end up being the same. It would be 4 and 4. Whatever you do to the denominator, you have to do to the numerator. So I'm also going to multiply the numerator by 2. We're allowed to do that because what we're really multiplying by is 1. 2 divided by 2 is just 1. So that's why we're allowed to do this. So our numerator is going to become 2 times 1, which is 2 over 4. Plus 3 over 4. And now we can add these fractions together. The denominator stays the same. We're just counting fourths. And we're going to add the numerators. 2 plus 3, which is 5. We can't reduce that any further, so we're done. How about this guy over here? I changed this denominator to 3. How can I make these guys the same? Clearly, I can't make 3 into 4 by just multiplying. 3 times 1 is 3. 3 times 2 is 6. So I got to multiply both of them. And do you remember what we can do from elementary school? We're looking for the lowest common denominator. And that can be done if I multiply this denominator by the other denominator and this denominator by the other one. So what I mean by that is if I multiply 3 by 4 and 4 by 3, then we're going to get the same denominator down here. We're going to get 12 and 12. So I can't just multiply a number just because I feel like it. I got to make sure I'm really multiplying by 1. So I'm going to multiply by 4 over 4 in this guy, which is multiplying by 1, 3 over 3 in this guy. So what we're left with is a numerator of 4, denominator of 12. And then we've got a numerator of 9 and a denominator of 12. And so we're going to leave the denominator the same, just like we did with adding. And we're just going to subtract these two. So 4 minus 9 is going to be negative 5 over 12. And we cannot reduce anymore, so we're done. So if you can remember this process from elementary school, we're just going to apply this now to rational expressions. So what about something that looks like this? So now there's polynomials involved. Because we're adding, same rules as this guy here. We have to make sure the denominator is the same. So the question is, how can I make these denominators the same? This denominator is x plus 2. This denominator is x minus 3. We have to make them the same through multiplication. So what if I come up with a lowest common denominator of the two of them multiplied together? So what if I make the lowest common denominator x plus 2, x minus 3? Similar to what we did up here. We made the lowest common denominator 12, and we came up with that by multiplying the two denominators together. It's not the only way to come up with the lowest common denominator, because here we didn't multiply 2 and 4 together. We looked creatively and realized I can make 4 out of this 2 by just multiplying by 2. So these are the two techniques we're going to use. In this case here, let's try using this technique, multiplying these two denominators together. So what would this look like? If I have to make this LCD, what would I have to multiply this fraction by? Let's put some brackets around here so I can start multiplying. So this guy here already has an x plus 2. We need to multiply by x minus 3. So I'm going to multiply this denominator by x minus 3. What does this guy have to be multiplied by? It's missing the x plus 2. So I'm going to multiply this guy by x plus 2. And then we remember whatever I multiply in the denominator, I got to do the same in the numerator. So I can do this because this guy divides and makes 1, and this guy divides and makes 1. So we're really just multiplying by 1. So let's see if this works out. On our first fraction, we're going to have 4 times this. I'm just going to put the 4 first, but it means the same thing. And then this denominator is now x minus 3, x plus 2. We have plus, in the next numerator, we've got 2 times x plus 2. Then the denominator, again, we have x minus 3, x plus 2. So now am I allowed to add these together? Well, just using our example up here with just regular numbers, these denominators are the same, so I can add the numerator. So I'm going to have one big denominator, x minus 3 and x plus 2. And then the numerator, I'm going to have 4x minus 3 plus 2x plus 2. So we're almost done, but we haven't simplified as much as possible. So to simplify it as much as possible, I gotta expand this. We are not going to expand the denominator. Here's why. The denominator is factored. Take a look at this guy here. It's completely factored. We have a term times another term. There's no adding or subtracting happening between these two factors. Up top, it's not factored. We have it like a partial factor. This part's factored, this part's factored, but then we have these two terms adding together. That means this is not factored. So don't expand this. Expanding something that's already factored, you're just undoing something you've already simplified. Up top, we want to make sure that there's nothing that cancels out with the bottom and the top. Notice I cannot cross these out. If your pen starts approaching your paper trying to cross these out, slap your pen out of your hand. Why? It's not factored in the numerator. So these aren't true opposites. This is not times x minus 3 divided by x minus 3. This is times x minus 3 plus 2x plus 2. No. So cannot cross those out because it's not factored in the top. So let's factor the top. And in order to factor the top, we first have to expand. So it's going to be 4x minus 12 plus 2x plus 4 all over x minus 3. X plus 2. We're going to keep on simplifying here. In the numerator, if we collect the x terms, we've got 4 plus 2x is going to be 6x. Negative 12 plus 4 is going to be negative 8. And then we've got x minus 3, x plus 2. Let's keep on factoring the top. We can take out a 2, so we're left with 3x minus 4. On the bottom, we've got x minus 3, x plus 2. Now the numerator is factored because I have a factor times another factor, no adding or subtracting between these factors. Unfortunately, nothing cancels out. So this is my final answer. So we are done. We're just going to list the restrictions and then we're completely done. So this is true if x cannot equal what? So let's start at the very top. We're going to start at the very top here. X can equal 3, x can equal negative 2. So those are our first two restrictions. Do we create any more? 3, negative 2, 3, negative 2, 3, negative 2. Nope, that's it. So just in summary, we're just going to do some more examples, but you know everything you know just from these two examples here. We're just going to create like denominators, just like what we would do with just regular numbers. Let's try a few examples. Let's try this guy here. We're going to simplify and state restrictions. Taking a look here, we have the same denominator twice. So the denominators are already equal. So that means we can go ahead and just add the numerator and leave the denominator on its own. It's literally that easy. So this is just going to be 7 over x minus 2, and we're done. Stating restrictions, we know that x can equal 2 based on this guy here and this guy here. And it's literally that simple. That guy's done. Let's try something slightly harder. What about this? So it sometimes can be difficult to just look at it and be able to know what the common denominators will be. Notice that we're doing subtraction this time. We're still following the exact same steps though. So it can be difficult with these polynomial expressions to be able to tell just by looking at what the lowest common denominator is. So let's work it out. It is not always ideal to just immediately multiply these two. If I were to multiply these two, the lowest common denominator would be would be 12x squared, but I can make something smaller than that. Remember in this example up here, remember here, we could have made a common denominator of 8. Is it the lowest common denominator? No. We're actually making more work for ourselves because if we did change these to 8, we just have to reduce somewhere else. So can we get creative here? The lowest common denominator is not actually 12x squared. It's going to be something smaller than that. So let's deal with the number first. What's the lowest number that I can make 4 and 3 to? If you count by 4s, count by 3s, the lowest number that we can come up with, or coefficient we can come up with, is 12. But how about the letter? This one has x and this one has x. So what if I just make the lowest common denominator 12x? If you're unsure if this is right, you'll be able to know if you've got the answer right by asking yourself, can I make 4x into 12x? Well, yeah, all I have to do is multiply by 3. And can I make 3x into 12x? Well, yeah, all I have to do is multiply by 4. So haven't I now made both the same denominator? So again, it's not always the best answer to multiply these because it's not going to always give us the lowest common denominator. We have to think about it. What's the smallest number of factors I can put there? So let's finish this off by multiplying the numerators by the numbers we chose as well. Remember to put brackets around because we're going to be expanding. So taking a look here, on the top we've got 3 times 4x minus 3 all over 12x. Minus, we have 4x plus 2 all over 12x. And we're brilliant. We made the same denominator twice. So now let's keep simplifying. So we got the same denominator, so we're going to make this all over 12x. I'm going to write this out step by step for this one, but then we're going to start skipping steps moving on. So here we go. Notice there's nothing I can cross out with the denominator because it's not factored. So the last thing I'm going to do is quickly expand this, simplify, and we'll see if we can factor and see if anything cancels out here. So we're going to expand this in here, expand this in here. So we're going to have 12x on the top minus 9, negative 4x minus 8 all over 12x. Continue simplifying. The numerator, our x terms will become 8x. Then we have negative 9 minus 8, which is going to be negative 17 all over 12x. Nothing factors on the top, so we are done. We're going to just state some restrictions, and then we can finish this problem. Taking a look all the way up here, what are the restrictions in the denominator? We've got 0, we've got 0, 0, 0, 0, 0. That is our only restriction. X cannot equal 0. Hopefully you feel like you're getting the hang of it now. Let's try 2 more together, and then you're going to try 2 more on your own. All right, so we can immediately start subtracting these, right? Because the denominators are the same. Wrong, they're not the same. This guy is so close to this guy, but it's not exactly the same. So I'm going to try factoring the denominator first. I'm going to leave that x minus 1 alone, and I'm going to take out a negative 1 out of this guy here. So if I take out a negative 1, I'm going to be left with positive x, and then 1 divided by negative 1 is negative 1. Now these denominators are the same, or almost the same. I apologize. What is the lowest common denominator that I can create? It definitely has to include x minus 1 in it, but how can I make this one look like this one? All I have to do is multiply by negative 1. So our lowest common denominator, the smallest denominator I can make, or the simplest, is negative 1 times x minus 1. This one doesn't have to be touched. This other guy just needs to be multiplied by negative 1 on the top and bottom. We're going to make sure we put brackets around there. And let's simplify. So let's skip some steps if we can. So our numerator is going to be negative 1. Our denominator is going to be this guy minus 1 over this guy. Let's immediately just subtract these two. So in the denominator, this is what I've got. In the numerator, I'm going to have negative 1 minus 1. I'm going to have negative 2. Can anything be simplified any further here? Well, taking a look at these two negatives, we know a negative divided by a negative is a positive. So I'm going to change this to 2 over. That's just going to be positive 1. So I just have x minus 1, and I'm done. What are our restrictions? X cannot equal what? X can equal 1 here. Also, x can equal 1 here. 1, 1, 1, 1. Our only restriction is x can't equal 1. In this example, I want you to come up with the LCD on your own. So pause the video and see if you can figure out what the lowest common denominator is. If you're back at the video, you have found the LCD or attempted it. What did you come up with? First of all, did you try adding a here like this? Are we allowed to do that? Nope. We can only create lowest common denominators by multiplication. So the only lowest common denominator, or the lowest common denominator, is going to be both of these things multiplied together. So it's going to be b times a plus b. So I'm going to multiply, I can multiply this guy by a plus b and multiply this guy by b, and I'll create that lowest common denominator. We cannot create those LCDs from adding and subtracting. So let's finish off by multiplying the numerator but by whatever we did in the denominator. Let's simplify this quickly. We've got b times 4a. Can we just expand this as we go? Or expand this, simplify. b times 4a, right up here, is just going to be 4ab. So I'm just going to write 4ab all over ba plus b. And then can we expand this guy too? 2 times a plus b is going to be 2a plus 2b. So we got plus 2a plus 2b all over ba plus b. Let's add these numerators together. So we have our denominator down here. Then we've got 4ab plus 2a plus 2b. Let's factor the top. So we're going to have ab plus a plus b all over ba plus b. And nothing can be simplified any further. We can't, there's no common factors in the top and the bottom, so we're done. We're just going to write our restrictions. Taking a look here, we have a restriction that b cannot equal 0. So we're going to write that as 1. Our other restriction comes from a plus b can equal 0. So if you can't figure out that restriction, just make yourself a little equation. A plus b cannot equal 0. And then either isolate for a or b. It doesn't matter. Since I already have b here, I'm going to isolate for b. So b cannot equal negative a. So that's our second and last restriction. You can check all the way down here and all the restrictions will be the same. So now we've come to our final examples. So these ones we can totally do. They're very similar to what we just did, except look at the denominators. It's really hard to figure out how I can make these denominators match. Remember, we can only make them match by multiplication. So what do you think we can do to make this easier for us? Are you thinking factoring? Because then you would be right. So a key part in adding and subtracting, just a rational expression, just like when we're multiplying and dividing, so we have to make sure everything's factored first. So far, most of the ones we've done so far have been factored, so it's been easier. So we have to factor each of these separately. So we're going to factor this guy, and we're going to factor this guy. So this first guy, we've got w squared plus 5w plus 4. You can go ahead and do your own steps of factoring, and we will get this answer. Just skipping some steps here, just you guys know how to factor now. If you don't remember how to factor these guys, remember we can use the shortcut of decomposition because our leading coefficient is 1. So this guy is going to factor to w plus 4, w minus 2. Okay, so we're going to put everything back. So we got 3w minus 4 all over. We've got w plus 4, w plus 1, and then we have minus 2w minus 3. Notice that the numerators can't be factored. There's no common factor there. W plus 4, W minus 2. So now we have to come up with our lowest common denominator. What is our lowest common denominator here? What has to be included? So how can I make this one look like this one and vice versa? Well, what's in common with both of them? What's in common is W plus 4. So W plus 4 must be a part of the lowest common denominator. What else must be a part of it? Well, it has to have a W plus 1 in it, because that's another factor we have. And it has to have a W minus 2 in it. That's a third factor we have. So once you're done with your LCD, you don't have to think about it too hard if you have it right, because you can go and see if you can make this denominator out of what we have here. So this guy here, what do we need to multiply by to make this denominator look like this? We have a W plus 4 already. We have a W plus 1 already. We need to multiply it by W minus 2. So that's what I'm going to do, multiply by W minus 2. How about this guy? It has a W plus 4. It has a W minus 2. It's missing the W plus 1. W plus 1. Here we go. So I'm going to multiply in the numerator as well, making sure to add brackets. We're going to add some brackets here. I'm going to multiply by the numerator, W minus 2. And now we're ready to just simplify. So let's skip some more steps here. Let's just start subtracting these now that we know the denominators are the same. Okay, they're exactly the same as this. Let's just start simplifying the numerator. So I'm going to leave the denominator alone. So W plus 4, W minus 2, W plus 1, whatever order the factors are in, that's fine. In the numerator, I've got W minus 2 times 3W minus 4. So I have to FOIL this. Just like this one, I have to FOIL. So let's FOIL this quickly. I've got W times 3W. That's going to be 3W squared. I've got W times negative 4, that's negative 4W. And then I've got negative 2 times 3W is negative 6W. I've got negative 2 times negative 4 is positive 8. And then we have minus this guy. So here's what's really important. Because there's a minus there, we have to put big brackets around this. Big brackets around this like this. Because that negative, this negative here has to get expanded in here. So we're going to put negative, and then I'm going to put some big brackets here, and now we're going to expand this guy. So 2W times W is 2W squared. 2W times 1, we got plus 2W. Then I've got negative 3 times W is negative 3W. Then finally we have negative 3. So this one, lots of algebra. Lots of algebra. Not too hard. It's just that it's a little bit time consuming. So let's keep simplifying this guy now. I'm going to copy down that denominator. That's so nice and simplified here. Change that to W. W plus 1. Let's start simplifying the numerator. So is there anything I can simplify here? I've got 3W squared. I can make that into negative 10W plus 8. Hopefully I haven't made an algebraic error so far. I'm going to multiply this negative in here. So I've got negative 2W squared minus 2W plus 3W plus 3. Woof, are we done yet? Nope. Keep on going. We're almost done. Let's keep simplifying that numerator. We're almost there. On the denominator, we got this W plus 4, W minus 2, W plus 1. Okay, let's see. We got W squared. 3W squared minus 2W squared is just W squared. Let's do the W's now. We got negative 10 minus 2 plus 3. So negative 10 minus 2 is negative 12. Plus 3 is 9, right? Negative 9. So we got negative 9W, and then we got positive 8 plus 3, 11. Are we done? Can we factor the top? Because we're looking for things to cancel, right? Two numbers that multiply to 11 add to negative 9 don't exist. So hopefully I didn't make a error somewhere down here. I know if I did, someone will catch it, and we will correct it together. But based on my calculation, there's nothing else to simplify. So we are just going to Choose our restrictions. So W cannot equal what? 2, -4, and -1. So those are our restrictions. And now you're done. Now this is complicated as it gets. So now you know how to add and subtract all rational expressions even when they're not factored.